Strings can be set to null, rather string references can be set to null. So here I have two strings as an example, and so this string supposedly is allocated, so this text hello is allocated somewhere, and there's an object that holds this value. Of course, this string reference is set to point to this string, and later we can use this last name to access all of the functionality of this string. In this case, when we indicate null, string reference is just initialized with all of its bits equal to 0, and in diagrams we sometimes we show this by using like a square box with a cross, diagonal crosses like this. So this kind of indicates that this is not an object, this is really a null reference, and most of the time this is done intentionally on purpose, just to make it clear that the string references are set equal to null. So you can obviously check whether reference is null or not null. And just a quick reminder that using equal sign between two strings is not a good idea if you're trying to compare the actual content between strings. Remember, to compare these strings, you really have to use equals or equals ignore case method that is built into the string objects. So this is just comparing string references. Sometimes you want to compare whether the two references pointing to the same object, like in this case, right? So if I set this equal last name, then I have two references that are pointing to the same object hello. But you know, in cases where you're really looking at the content of the strings, you don't use equal. What you should be doing is, if last name here, it's kind of silly example logically, but we say equals, for example, to the first name, something like that, then we're going to be doing something. Okay, so that's just an example. But at the same time, if one of the objects is a null, let's see what happens here. We're going to say system out print line, and we just print some kind of message. Strings are the same. So let's observe what happens if the first name that we pass as an argument to equals is a null. How does it behave? What is it going to do? So let's run this, and you can see that the result of this is that equals method did not fail. It accepted the null and decided that there is no reason to compare something like this. If I flip these two strings and use first name, which is now null, and use the second string, which is last name, but look, this is null, and we're now trying to use this as a valid object reference. Of course, this will be not looking good at runtime. If I run this, we get a null pointer exception. So null pointer exception tells us that this string reference contains all zeros, also known as null pointer or null, and you're trying to use it as if there was a real object that this reference is pointing to, but no such object exists. So its method cannot be invoked because there is no object, and therefore you get this exception error like we do right here. So just a quick reminder, since we're talking about operators that compare primitive data types, just a reminder that with strings you have to use methods, and you have to be mindful that they can be null sometimes. Logical operators. Logical operators, let me give you an example. For instance, I want to maybe to check whether the first name is a null. or the last name is a null. Okay, so both checks like this. And this is a logical OR operator, so it compares basically what it does. It evaluates the first or rather left-hand side sub-expression, and of course in our case it will be true, because first name, yes, it is a null. So this will be true. So then regardless what this case is, this will be also true. So here we should probably say something like null string, right? So whatever, just to print something. So let's run this. Okay, so it prints null strings, or null string rather. Okay, and so there is this is a logical OR operator that is true when at least one of them is true, and logical AND operator, I'm not going to change it, but if we use 2 ampersand, then logical AND operator would evaluate this side first, and if it's false, it will actually ignore this part entirely, because it's enough for this to be false to result. I'll put it in actually because it's obvious now. Right, so if this is already false, then this is never evaluated, and AND logical operator would require both sides to be true. In our case, this is actually true, so this will be true. And AND requires both sides to be true, so it will obviously checking this, and this will be false. So it will not be printing this message. So do not mistake logical AND and logical OR with bitwise operators AND and OR. These are totally different operators, and we'll talk about them much later on in our course. There's also logical NOT operator. So logical NOT inverts the the value of true or false. So true becomes false, and vice versa. So if you want to do that, you can do it like a logical NOT operator. And I already told you that both of these, logical AND and logical OR, have this notion of short-circuiting in case if the operator, which always evaluates one side, detects that it's already true or false, it may decide that the other side is not necessary to evaluate. It comes mostly important when somewhere here you're making a method call into another part of the program. So this method call may not take place if this operator somehow short circuits its evaluation.